guys. And uh, even I asked you guys some questions in the that forum that if you want to share any scenario-based question or any question which you have faced during your interview, without breaking the NDA, if you want to share it, I will include this as a part of our next session. Okay. So the question is, provide a guidance on how to troubleshoot a slow server in Linux, offering potential method and tools for identifying and resolving a performance issue. So basically, the interviewer, they have asked you that one of the server, it is responding slow, and your work is to debug or troubleshoot that why it is responding slow. I mean, this is one of the most common question they have asked. So I want to ask you guys, where exactly you guys going to start?
The boot processor, like uh, we can
So
have.
Prashant, just a
Yes, sir.
clarification, your server is already booted. Now the question is like your system is responding slow.
I think we check the top processes and like the resource load, like CPU memory loads.
Yes, exactly. What else we can check? Disk, exactly. Other thing, Harish, I will stop you for this one, this application logs, but I will come to this later. But home drive, maybe, maybe not. Himanshu, I'm talking in terms of server, not the user desktop or laptop. So just concentrate in terms of server. Network, exactly. Okay. Yeah. Enough. Yeah. I mean, these are really good suggestions, and that's what I want to listen it from you guys. Or so basically, during the interview, whenever the interviewer asks me this question, I always cross question him whether he wants to debug this issue from the server side or from the application side. So like some of the suggestion which you guys given it to me, they are basically from the application side, and the application side, it's a completely different debugging. So basically you can check the logs. Okay. But that will go to the completely different spectrum. So we don't want to go into that rabbit hole and try to debug from the application side. So basically, that's what I always want to play it from the interviewer. You want it from the server side or the application side. So for the next 10-15 minutes, we are going to debug it from the server side. Okay. But where exactly we are going to debug? Okay. So that's what, again, I want to build that mental model, like how you guys are going to approach to this kind of a problem. So far, in the last 30 or 40 minutes, you understand that for system, kernel is everything. Kernel is the one who is doing the memory management or IO management or whatever you can say. It is doing all these things under the hood for you guys, right? Memory, IO, disk, right? IO or disk, they are the same thing, or CPU, right? Or network. I'm going to talk about the network soon. So kernel is everything for us. But ultimately, if you think about these things, if you think of like instructions, so for example, your Apache process, I'm taking the example of again the Apache process, that is ultimately at the end of the day is being executed on CPU, right? CPU is the one who is getting the instruction and get your process executed. Or if the requests they are coming, like for example, this Apache, it is hosted on, let's say, www.xyz.com. So ultimately, at the end of the day, there is some network IP which is associated with this server, right? Or this domain. And that will be running on some kind of a network card, right? DNS and all those, they are later come into picture, but it is running on some network card. And in that network card, you are receiving a traffic, and that has been again been served by some CPU. Similarly, any process which you are running, before it is being executed, it is first load into the RAM, right? And from RAM, it is been executed by CPU. And it is going to be stored in your disk. Okay, so the point I'm trying to drive here that kernel is doing all this memory management or all these tasks, but ultimately at the end of the day, they are being performed in some kind of a hardware, right? Or if you go with this, all these Amazon EC2 or any kind of a virtual solution, you are getting some kind of a emulated hardware. But they are hardware in some sense, right? Under the hood, they are running some hardware. So your performance debugging lies on these 4 important points. One is CPU, second one is memory, third one is network, or fourth one is IO or disk. Okay. So you guys already gave all these suggestions. So let's try to debug this one by one, right? So first, let me go to this Linux system and I will show you I'm running the CentOS 7. So first, without installing any package on the top of this, I want to debug an issue. How can I do that? Okay. So first command that I'm going to run to see how my CPU is doing is called W command. Okay. And W gives you the load average for this 1 minute, this 5 minute, and this 15 minutes. So if I execute this W command, I mean, I don't need to run any fancy tools. I just run this W command, and this will give me the load average for 1 minute, 5 minutes, and 15 minutes. Okay. So W is one command. Do anyone know there are 3 popular W commands? 3 popular W commands. What are those? W is one of them. What are the other 2 other W commands which are popular? There's a big Reddit post for that. Who am I? Yes. Yes. Actually, it's called who, which will give you who logged into your system. Who am I is one more. And there's something called which command, which will read this path variable, right? And it will give you where exactly the binary is located. So even who am I is there, but if you go to the kernel, Linux kernel thread, they will give you this command w who, and even if you go who-r, it will give you the run level in which your system is booted. This is CentOS 7, so this is systemd, so it doesn't matter. And the last one is which command. Okay. So the first thing which we have debugged is that, okay, my system is doing okay, so it's not a CPU issue, right? This is very low, and I can check in proc CPU info how much processor this system has. So the system has 1, or it starts with 0, so 0 and 1. So this system has 2 processor, and there's one more handy command called lscpu. This will give you like a brief, concise output and the number of CPU which is present in the system. The one thing which I really like about this command is even give me the L1, L2, or L3 cache which is attached to this CPU. Okay. So this is lscpu. So we have find it out that, okay, our system is doing well in terms of CPU. The next thing which we are going to target is called memory. Okay. So once again, I am not installing any package in the top of this operating system. I want to debug it, whatever the existing package which is present in my system. So I am going to use free-m command. Okay. And please, whenever you look at the output of this free-m command, it is going to do something called never looked at this free column, always look at this available column, because this is the shared and the buffer cache. So in case if your system is running out of memory, kernel is going to reclaim that memory by pushing this data back to the disk. So always look at this column available. I already wrote a blog regarding this, Linux ate my RAM. So basically you need to look at this column to see if your system is doing well or not. Okay. So second command we have run is called free-m. And here we have checked, okay, my system is doing well because out of this 8 GB, I have like close to 7 GB of memory available. And just to tell you, this free-m is going to tell you the output in megabyte. If you want to see the output in gigabyte, you can do free-g. But when you use this -g flag, you will lose precision. So I will always use this free-m. I think it's -k for kilobyte and -b for bytes. So if you need this much amount of precision, you can use this free with these different options. Okay. Guys, let me finish this and then I will come back to your question. So basically, we have looked at this w command, we have looked this free-m command. So my system is doing well in terms of memory. Okay. The next thing is network. Okay. So network, I can run this command called ifconfig. Okay. I know many people, they are not using it anymore, but if I run this ifconfig command and I will look at this rx error, right? And this tx error. This is for the receive and this is for the transmit. So during when this particular server is receiving any packets, or when this is transmitting any packet, this is if this server is dropping or any packet getting error out on this particular server, that I can check with the output of this command. Okay. So I have checked it and this server is doing well. Now I have run this ifconfig command, and many of you know that in many of the distribution, this command is deprecated, right? So if I run yum, it's like- and this command is now being replaced with IP command. Do anyone know why command is now replaced by the ifconfig command is now replaced by the IP?
Is it because like we don't have IPv6 something? Yeah.
Yeah, functionality is one thing. Any other reason?
I think the new network drivers, which is the 1000 or like something, which is coming, high drivers, which is not compatible with.
I am not sure about it if those are compatible or not. So first reason is obviously that this command provides more functionality. So for example, if you want to add a route, IP route, you can do it with the help of this command. But so for example, if you look at this ifconfig command, this comes from this nettools package. And if you look at this switch IP, this comes from this IP route package. And okay, let me do this quickly. Trace. So if you look at this, the S trace or system trace, we are going to discuss about it in one of the question. It uses something called this IOCTL call, which is called input output control. So basically what this system call is doing is that during using this system call, your application, or in this case, this ifconfig, is able to control the parameters of your network interface card. So I can give you this diagram. So basically this ifconfig, under the hood, it is running this IOCTL system call. And using this, it is going to control your network interface card parameters. Okay. And this is not been actively maintained anymore. While this IP, which is coming from this IP route package, this is now being actively being maintained by the community. Which actively maintain, I mean, if there is any bug fix or any new features like you guys have mentioned coming, they're actively supporting it. So that is one of the reason. I mean, it's not a technical reason, but because it has been supported by community, it has been more popular nowadays. So rather than using the ifconfig command, people are now, you will see that people are using IP address show or IPADDR list, all these commands. Okay, so I know we have drifted from where exactly we are going, but just to give you the idea, like some, because of some of these parameters. And finally, we have this IO. So for that, again, I don't want to install any package. I can use a command called top. Okay, and in the top there is a column called this 00.wait. Top this way. So basically, what this is telling you that your app, it is trying to write to a disk. Like I mentioned, ultimately our main goal is that the application is going to flush or write all the data to a disk. But your disk is already fulfilling some other requests. So all your application or all your requests is going to a queue. And queue means wait. So if you see a high wait over there, that means your disk is not as fast. Once again, I'm just giving you some high level. There may be a n number of reasons, but queue means, or a wait means, your disk is not responding as fast as it is supposed to be. So that's why you are seeing a wait over there. Okay, so let me summarize this. Using a W command, we have looked at the load average. Using the free-m command, we have looked at the available parameter. Using the ifconfig command, we have seen this TX and RX packet. And finally, looking at the IO command, we looked at the wait. Okay. We haven't installed any utility on the top of it. Maybe ifconfig, because ifconfig is not supported anymore. So you might need to install this net-tools package to install this utility. But except for that, we haven't installed any utility. Now, looking at these output, what do you think? What is the first limitation you are seeing by looking at this output? I mean, I have all these output. Let's say my load average, let's assume that because I have a system which is having only 2 CPU and I'm seeing the load average of 20, right? So by looking at all these output, I'm able to pinpoint out that the issue is due to the CPU. My CPU is overloaded. Okay. Or maybe the RX or TX error is high. Let's say is, so I know there's something going on with the network card, or this weight is like 150. So I see there's something is going on with the IO weight. But what exactly I'm able to deduct out of all these output? Exactly, David, you're on the point. Like, I don't know which process, or Chaitanya, even absolutely correct. We don't know which process or which application is causing this. I'm able to narrow down the issue that it might be due to CPU or it might be due to IO or network. But at this point of time, looking at all these tools, I have no idea which process is causing this. So now we are coming to the second phase, where we will see which process is responsible for this one. Okay. So again, we will start with the CPU, right? And for that purpose, we are going to run a command called top. We have already seen that. And similar to top, top is also a combination of this output called. So if you look at the first column, you will see this 00105, which is similar to what we have seen in the W command. But you also see this CPU utilization, which process causing the high CPU. And by default, top sort out the process with the CPU utilization. So the process which is consuming the highest amount of CPU, it is shown at the top or the first column. Okay. And one tip for you guys, if you press 1, you will see the CPU utilization breakdown per CPU. Otherwise, at the earlier, you will see, I don't know how to go back to this. But if you see, this is going to be the average sum of both the CPU. In this system, I have two CPU. But if you press 1, you just need to press one key. You will see what exactly going on at each CPU level. Okay, so this is one nice tip which everyone should remember or everyone should know. So here I have seen that, okay, this process might be responsible for causing the high CPU. Okay, so I'm able to filter it out by using this stop command. So this is for CPU. Now I have told you just right now that top by default sort out process based on CPU. But if you type Shift M, let me type here, it's called Shift plus M. Now top will start sorting out the process based on memory. So the process which is consuming the highest amount of memory, it will show in the first in the output. So you just need to press the Shift -M, and then you will be able to pinpoint out, okay, this process consuming the highest amount of memory. Okay. Okay. So we have filed it out CPU and memory. The next thing is the network or IO. Okay. Unfortunately, as far as I know, there is no tools which is available which will give you which will help you to identify which process consuming the highest IO. So for that, you need to install a third-party tool called IOTop. Provide us root privilege. And it will give you which process is doing the high IO, disk read or disk write. It is the part of the, let me type here, EPL extended package repository for Reddit Linux. And you just need to install something called IOTop. And after installing this IOTop, you will see the disk read or disk write for which process doing the highest amount of disk read or disk write. Okay. Now, question for you guys: do you guys know any other tool through which you can see which process consuming the highest amount of IO? Any other tool which you guys are aware of? Okay, I will take this as a no. And finally, looking at the network. So for that, we have a utility called dstat. Again, this does not come by default installed with your system. You need to install it. And the command for that is dstat -net -top -io -ad. Okay. -net is for network. This is going to enable your network statistics. And this top -io -ad is going to show you the most expensive IO process, like the process which is going to do the most amount of IO receive or send. Let me paste you this command for you guys. Again, this package does not come by default installed with your system, so you need to install this dstat. Okay. So now, with the help of these applications or these new RPM, you at least be able to pinpoint out, like, okay, this process is consuming the high CPU or high IO or high network. So let me summarize this for you. First thing, I always insist, check with the interviewer if he wants to debug it from the application side or from the server side. If it's from the application side, you might need to check the application log also, like why this application is responding slow. On the server side, we know that the kernel is the main thing which perform all the operation like memory management, disk, IO, CPU, but they perform all these things on the top of your hardware. And that's why we try to isolate this, the performance debugging using the 4 hardware parameters, your CPU, memory, network, and IO. First, we started with the W command, where we see the load average, right, for 1, 5, and 15 minutes. We looked at the free-m command, where we looked at the available column to see the amount of memory which is present in my system. We looked at the ifconfig output, where we see the number of receive and drop packets. And finally, we look at the top command and we see the wait parameters to see if there is any queue which is built on the disk side and is not able to accept the traffic. Okay. Now, one of the limitations with all these utilities is that I am not able to see that, okay, which process actually is responsible for creating a bottleneck in my system. So I started again with the top command. If I press the 1 key, it will show me the breakdown per CPU. And if I go with the shift-m, it will prioritize the process, or it will sort the process based on the memory. Now, similarly, I need to install a third-party package called IOTop, through which I can see which process is responsible for creating the high IO. And finally, the dstat, through which I can see the networking stat. Okay.